This presentation is about solving scheduling issues with AI while considering human factors. Currently, scheduling shifts for employees and maximizing preferences can take a manager hours each time. Currently, the managers have to know each employee's available time, their preferred working time, their total hours needed per week, and as per their contract and their roles. Evaluate upcoming workload and required roles in the next scheduling period. Pick the right people for the right jobs and enter them into time slots that maximize each employee's preferred time and also meet their required total hours per week. They also need to balance fair shares when some slots are popular and a conflicting scheduling time. Is AI the right tool for the problem? It is, because the data is large and complex. It creates an opportunity for machine learning. Multiple people, shifts, and preferences are complex data, but also can be predicted with patterned training. AI is a great fit in this scenario. This tool can save managers hours each time from creating a schedule that maximizes employee satisfaction. How will users interact with this tool? Employees can enter their available hours, preferred hours, and requested time off for each scheduling period, and the managers can decide how many employees are needed per role per shift. They enter prioritization based on the best way to run the business, and they use AI to generate a schedule. An AI can generate 3 schedule options based on pre-existing training and a manager's prioritization. Managers will pick the closest schedule, make some minor adjustments, and publish the schedule. The published schedule then feed back into AI learning system to continue training the system to match local business preferences. This tool will share where the training data was from and the time when the data was collected. And it will highlight the limitation of not aware of changes after, such as loss. Any privacy-related concerns should be protected, including personal identification on a schedule, time or place indicated on a schedule, and personal health-related time-off requests. User data should be protected. The user data should not go to the cloud. Employee schedules are private and not to be shared with anyone outside the team or org. Employees' health conditions are protected and shall not be shared with anyone on the system. Managers can choose and share a schedule with the team or not. Then employees can see their own schedule or see the team's schedule. The history of schedule to be kept as per laws and business policies. Training data is also to be controlled. The training data will not have any identifiable information back to a person. Everyone's name will be replaced by numbers. If any features are found to be critical to generate an accurate output, we will review with compliance and policies. There are some applicable laws to my product. For example, personal health are protected by HIPAA, and make sure personal health information are confidential and not shared with anyone. GDPR are to be used for EU users. The main potential source of bias would come from the manager's personal preferences. It could be over religion, gender, age, health condition, and family situation. How my product can meet the 3 goals of ethics of AI? Fairness. The outcome of the training data will by default make everyone equal and train based on existing data. The goal of the outcome is to learn the manager's preferences and output a schedule that he would have made and save his time. The goal is not to output an absolute fair schedule for every individual, since managers can decide their own priorities, visions, and focuses. Accountability. If there is an issue, we'll provide a way for users to contact us. Transparency will notify users about how their data will be used. Here is a crisp design process for the scheduling tool. First, the business understanding is that workplace with shifts need a faster way to schedule. And data understanding is that both employees and employers can enter the required data, and AI will generate the schedule, and then the schedule being used will feed back to more AI training for local business. To prepare for training data, we will collect 1 year of data from 5 organizations, including large and small, and use 80% to train and 20% for validation. There could be bias coming from the data, training data, which includes religions, local cultures, age, or temporary events. To select the features, we'll use statistic correlations, and to choose algorithm, we'll focus more on accuracy instead of efficiency and ability to interpret. We will choose linear regression and neural networks, and use k-fold validation to see which method works the best, and then pick that one.